Hello everyone, is it audible to all of you? Okay. So, hello everyone, I am Dr. Sunil Kumar Srivastava, and today in this our lectures of basic mathematics, we are going to discuss unit number 7. That topic is the polynomial. And this is the topic. I think you are all of you are familiarized with the our your previous classes, class 9th, 8, and that's it. So this is the too much interesting here topic, and we are going to discuss step by step details of this one. What is the meaning of polynomials and what is the details in this topic we are going to study here. So before going to start the sessions, we have to follow the read the some guidelines that you have to follow during our sessions here. And we are all of you know this guidelines. You have to maintain the discipline for a smooth conduction of interactive live sessions. You have to type your name, enrollment number, program name in the chat box to mark your attendance here. You have to raise your questions only after completion of the sessions. Do not interrupt between the session. Avoid posting any irrelevant questions. Also, do not start any personal conversation during our session. Interaction with the faculty should be constructive and no destructive comment is appreciated. For any issues, please contact with the given academic support services. Yeah, you can post your queries to the given email ID, that is the IMS manager underscore CDOE@bgu.ac.in. And before going to start the session, we have to first know what is the learning objective of this session. What is the learning objective of these sessions? So, first of all, by the end of the session, you will be able to understand. First is that identify the degree, leading coefficients, leading terms of a polynomial expressions. In a polynomial expression, we find identify degree, identify the coefficients, and identify the leading terms. Next, we have to perform algebraic operations on the polynomial expressions. And finally, identify the greatest common factor for a polynomial expressions. So these are the some learning objective of the sessions. Now, before going to start the session, we have to come across the some introduction points. What is the meaning of the polynomials and what is the why we are going to read here. So we are going to start the session in very descriptive way. And if you find any difficulty during the session, you give the comments in the comment box and I will surely give the answer with you. Okay. Now, what is the meaning of polynomials? The polynomial is a word that is derived weak words. That is the meaning of poly. The polynomial have the two words, that is the poly and nomials. The first meaning, the poly means many and nomials means terms. Any expression containing many terms is called a polynomials. That is sweet and simple language. In the sweet and simple language, any expressions which contain many terms. Suppose an expression of the form we have x square plus of 3x plus of 4. So this expression have the three terms, 1, 2, and 3. So this is the polynomial expressions. So any expression containing many terms. A polynomial can have number of terms but not infinite because it have the number of terms too much, greater than 1, greater than 5, greater than 100, but not infinites. Okay. So before going to start the definitions, polynomial expressions are algebraic expression that consist of variables and its coefficients. Any general expression of a polynomial expression is of the form is like that x raised to power of n plus of a1 x raised to power of n minus 1 plus of a2 x raised to power of n minus 2 and so on. And this is the polynomial expression in the variable x with a degree n and where a naught is not equal to 0. This is a condition. Coefficients of a naught is equal to 0. We define this definition in next. But first of all, we have to know what is the exact meaning of the polynomial. So polynomials are algebraic expression that consist of and variables and coefficients. A polynomial is defined as an expression which is a combination of variables, contest, constant, content, constant, constant, and the exponents that are coupled using the mathematical operations such as the addition, subtraction, multiplication, and divisions. No division operation on the variables. For example, we have an expression of the form 3x square plus of 3y minus 5. Here we have the coefficients. We have the variable x, y. We have the 3, 3 and minus 3 as the coefficients of the terms and respectively of the constant terms known as the constant sums. So here x and y are here the known as the variables. For any expression, polynomial expression is the nothing but is an expression in the variables form consisting of the variable constant and the exponents which are combined in the mathematical expression form such as the addition, subtraction as the multiplications. So any expression of this form, suppose we have expression 3x square plus of 4x plus of 9. This is a polynomial expression in variable x with the three terms 3x square plus of 4x and plus of 9. Any expression, any terms which is the free from the variables is known as the constant. Is known as the constant. Here in expression 9 is the constant. Here expression 4 is the constant. Here the term 5 is the constant. So any expression in the terms of the variable and free from the variables is the term as the constant. Now we move forward. Standard form of the polynomial. How to define? How to define? So this is the standard definition of a polynomial expressions. A polynomial in one variable x with degree and can be expressed in any expression of the form. Suppose we have the expression a n x raised to power of n, a n minus 1 x raised to power of n minus 1, and finally a1 x and a naught is equal to polynomial expression the variables. So any expression of this form where an minus 1, a2, an are known as the coefficients of all the terms that x raised to power of n, x raised to power n minus 1, and x square and x respectively. And these an x raised to power of n, an minus 1 x to the power minus, these are known as the terms of the polynomial. These are known as the terms of polynomial. These are known as terms of the polynomials. If a naught is equal to a1 is equal to, if all the constants are 0, this is known as the zero polynomial denoted by 0. And degree of zero polynomial is not defined. So we come across the points in the general expression. Suppose we have expression, we have a polynomial expression, the variable x, px. We notice px, yeah, qx, gx, like that. Expression the form x cube plus of 3x square plus of 6x plus of 9. So this have a polynomial expression in the variable x, where the coefficient of x cube is not equal to 0. So here this is known as the x cube is known as the terms of the polynomial. 3x square is also known as the terms of the polynomial. 6x is also known as the terms of the polynomials. 9 is known as the terms of the polynomial, that is the constant term. And the expression, suppose we have the expression, this is written here, that is the expression we have written here 3x square. This is the terms of the polynomial, but it's combined the two terms. That is the one is the 3 and that is the other is the x square. So x is the variable and 3 is known as the coefficient of x square. That is the coefficients of x square. So we can find here, if we ask you, what is the coefficient of 5x in, what is the coefficient of x square in 5x square? Yeah, what is the coefficient of, and what is the coefficient of x square in this expression? The answer is 5. What is the coefficient of x cube in this expression? The x cube coefficient is 9. If we ask you what is the coefficient of x raised to power of 4 in this expression, the answer is 2. So any expression that is written in the form, that is, suppose we have x square written here, it is nothing but is written the product of two terms, that is the 1, and another is the x square. The coefficient of x square is 1, is 1. Coefficient of x square is here 1. That is the coefficient of x square is here 1. So we have to know the clarity of the functions. Clarity, what is the variable which changes the position? Any expression in the form of the variable, it can change. It can be changes of our choice. Where going to value is going to be evaluate. Suppose I am asking you one price of 1 pen is 3 rupees. And going to find out the price of 100 pens. So you can change the variables. 100, 200, that is the variable quantity, and change the values of all the things. So can be expression can be taken as the expression form, that is known as the expression. An expression in the terms of the algebraic, that is known as the polynomials. And polynomial has the two much constant. What is the variable? What is the degree? What is the terms? What is the coefficients? Okay. Highest power expression present in the equations. Highest expression. Here, x raised to power. X raised to power 4. We read here. X raised to power 4. The highest power of x, that is the 4. Here, highest power of x is the 3. X raised to power of 2, and x raised nothing, x raised to power of 0. Okay. So in this whole expression, we find highest power is 4. So degrees 4. So we define the polynomial, a polynomial expression in the variable, in one variable x with degree. We have to denote the maximum exponent of that. Okay. So polynomial in one variable. So we are just describe with you what is the polynomial x one variable. Then we describe the polynomial in other two variables and more that. So what is the meaning polynomial in one variables? First of all, a variable is denoted by symbols that is known as the real values, that can take the real values. So these are generally used by the letters. Suppose we have the x, y, z, u, v, w, t, etc. We use this letter to denote the variables. Okay. And constants are denoted by the letters, that is the A, B, C, D, E, and so on. So here there is a difference between here. However, there is a difference between a letter denoting the constant and a letter denoting a variables. When we are always we are going to denote a variables, we use the letters x, y, z, r, u, v, w, x, and that's way. And we're going to denote a constant, you have to take the values a, b, c, and d like that. So this is the difference, and this pattern is followed for everywhere, for everything. So we are going to denote anywhere, denote the constant, we have to use ABC as the constants, and we're going to use the variables. Denote the variables, you have to use the expression x, y, z, u, v, w, t. That's it. Okay. So this is the difference between. The values of the constants remain same throughout the particular situations. That is, suppose here the expression it is written here x cube plus of 5x square plus of 9x plus of 6. So here 6 is the constant. Here 6 is the constant. It's a constant, have the definition constant. Okay. So its value is equal to constants remain same throughout the particular solution of the problem. We are going to solve this problem. This value of constant will always equal to the 6. That is, the value of the constant does not change in a given problem. Okay. But keep the variable can be taken as the changes. But variables value can be changes throughout the sessions, throughout the problem, throughout the conclusion of the problems. We are going to start, I can also explain with you. The constants are two types also. Constants are two types. One is the deterministics, which constant value is always same throughout the sessions, always same throughout the only problem. Suppose we have written is 6, this is the constant, but it will be applicable to the only this problem. But when we have the other type of constant, that is the absolute constant and arbitrary constant. There are two types of constant. That is, one is the absolute constants, another is the arbitrary constants. Absolute constant have the value fixed throughout the any types of problem. Suppose we know about the value of pi. Its value is always equal to 22 upon 7. If you are going to use the value of pi in the physics, always 22 upon 7. We are using the chemistry, physics, maths, anywhere. Value is always 22 upon 7. This type of constant is known as the absolute constants. But there are different types, that arbitrary constant. Arbitrary constant is the constant throughout the only problems. So 6 here is the only arbitrary constant categories. Next, if a polynomial contains only one variable expression, then it is said to be the polynomial in one variables. If any expression contains only one variable, any one variable, the expression is said to the polynomial in one variable. Suppose we have written expression here, px x cube plus 5x square plus of 9x plus 6. So this is the polynomial expression in the variable x. In the variable x, because here is only x is the variable and x is only one variable is here. Other is x is other variables are not. Suppose y and z will be also applicable. So we can write the variables in x and y. So here only one variable is here, x in x. And with four terms, one terms, first term, this is the second term, this is the third term, this is the fourth terms. So only four terms. If when the variable is a polynomial is x, then we denote the polynomials in like the px, qx, rx, and so on. For example, we read here, we have the polynomial in x. Px means, what is the meaning of this? We have a polynomial in x variable. That is the meaning. Here, py means we have a polynomial variable y. Pz means we have polynomial variable z. So we have the polynomial px. That is the variable, in a polynomial expression, the variable x. So we written in 2x square minus the 5x minus 6. This is the variable is here x. Here the polynomial of ry. The polynomial expression is y. So expression will be in the terms of y, because y cube plus y plus 1. This is the here variable is y. So as u, 6u minus u, and this one is the here variable is u. So if the variable in the polynomial is in x, we may write that denote by px, py, and qx. So expression of the polynomial, and we have to going to denote the polynomial in the terms of their variables. The variable is x, we denote in px. The variable is y, so we denote py. Variable is z, we note as a bz. Variable is t, we note as a pt. Now understand here. First of all, we have an expression is here, 3t square plus of 5t plus 6. This is a polynomial expression in the variable t. So we denote like that, p of plus of 9y plus of 6. So this is a polynomial expression. This is the polynomial expression variable x and y. This is the variable x and y. Not only in x, not only in y. That is the variable in the x and y. So this is the polynomial expression of two variables. This is the polynomial expression of one variable. So we have to very much clear about the concept. What is the degree? What is the polynomial? What is the expression? What is the terms? What is the coefficients? To interrupt your answer in very clear way. Otherwise, you will be always confusion. You will be in confusion how to answer, what is the meaning of that thing, and so on. So we move across degree of the polynomial. Degree of the polynomial. What is the definition? The highest power of the variable in polynomial is called the degree of the polynomial. We have the written a polynomial 2x square x minus 3. And this is the polynomial expression. First of all, we have to know this is the polynomial expression in the variable. In the variable x, in the variable x. This is the variable. So what is the definition? Highest power of the variable. The variable is x. Now we have to know highest power of the variable. This have the three terms. This is the one term, this is the second term, this is the third term. In the third term, this is written as 3, but it can be write in the power of, that is x raised to power of 0, because power of any variable is always equal to 1. So it can be written. So further, from the first term, we observe the highest power of x is here 0. Okay. Now second term, that is the 1 is x, and x raised. Nothing is written, we have the always 1. So from a second term, we have find x, highest power of x is equal to here 1. Okay. In the second term, we have the 2 term, 2 and x square. Here highest power of x is the here 2. So what is the definition? Highest power of the variable in the polynomial. In the polynomial have the three terms. One have the degree, one have the highest power 0, other have the highest power 1, and other have the highest power of 2. And in the same sequence, here are written as other polynomial q x cube. Here have only three terms, x cube and minus of 1. Okay. So highest power is here x cube. That is the degrees 3. Here written we have the variables in the other variable, that is written here x y square z plus 3y plus 5z plus 5. Here are three variables x, y and z. But in the case of the degree to calculate, we have to know the power of each and every variable. We have to add. Okay, let's see here. The variable is 5, its degree is 0. Okay. For this one, degree is 1. For this one, degree is also 1. But from this one, they have x have the degree 1, y have the degree 2, and z have the degree 1. So all have the mill completion, this one degree have the 4, because we have to add the power in this mixing of more than one variables. So we have the expression degree 4. We have to just add the power of each and every one. So 1 plus 2 plus 1, that is the 4, and highest degree is 4. So degree of the polynomial is here 4. Degree of the polynomial is here 4. Now next, I think you have understand the before going to start the characteristic of the polynomial. Once again, I repeat with you what is the polynomial and what is the terms, what is the degree. Suppose we have expression, we have written a polynomial expression. We have a expression of the polynomial, the variable x, written in the form here. Suppose written 3x cube plus 5 of x square plus of 6x and plus of 9. Okay. So what is the definition? This is the polynomial expression in the variable x. It's contained 4 terms. Number of terms here, number of terms is equal to 4. Okay. Variable is x. Okay. Degree is equal to highest power of the variables. So from here, highest power is 0. In the second, highest power is 1. In the third, highest power is 2. But in the term 3, we have highest power is 3. So degree is here 3. So any polynomial expression have the variables, terms, coefficients of the variables. It should be the clear, because we are going to apply the things. Okay. So characteristics, first is that closed under the addition and the multiplication. Closed means if we have a polynomial a and we have another polynomial expression b, and if we add them, the result is also a polynomial expression. So that is process known as the closed. Suppose we have a number 3, other number is 5. If we add the two natural number, 3 is also natural number, 5 is also natural number. So if you add the two natural number, result is 8, and it's also a natural number. The meaning is that if a and b are some elements of any particular thing, their composition is also is the set element of that set that they are said to be the closed. So he written a closed under the addition and multiplications. In the same way, the sum or product of two polynomials is also a polynomials. Defined for all the real or the complex numbers, polynomials can be evaluated for any values of x. That is the context here. Now, definition and the degree of the polynomial. Just we have defined with you and discussed with you in detail. Degree. The highest power or exponent of the variable in the polynomial. The degree indicates the highest dimension or order of the polynomial. Suppose you have a polynomial expression a n x raised to power of n, a n minus 1 x raised to power n minus 1 and last to a n naught. Where a n is not, mean coefficient of x raised to power of n, that is the a naught, a n is not equal to 0 because it becomes 0, degree reduces. So this expression is the polynomial expression with the degree of n here. This is the polynomial expression with degree n here. This is the polynomial expression with degree n. This suppose when in expression we have the more than one variables, so we write in the terms of the other function or two. Just like we have the expression in the polynomial expression of the form of xy. So it can be written as x square 3xy and plus of y square. So this is a polynomial expression with degree 2 because each term have the degree 2. So this is the polynomial expression of degree 2, but it can be written in the form of u is the function of that one xy because this is a polynomial expression of x and y variables. So you can write u or you can take the value p also. P also taken. This is x comma y. It can be written in the form, not xy. You cannot write like that because it denotes the one quantity. It denotes the two other separate variables. So we have to give the comma between the variables for that one. This is the x square plus 3x plus y square. This is the polynomial expression, but in the two variables, x and y. But each of degree of each. This is also 2. For each also here 2 and here is also 2. So degree is 2 here. But this is the two variables polynomial expressions. So it should be the clear in concepts. We have the same expression results for the three variables also. Now move forward. Types of the polynomials based on the degree. Definition based on the degree. First of all, constant polynomial. Any polynomial expression with degree is 0. Suppose expression the x is 7, 6, any expression constant. There is not nothing but you have the constant because it's a degree of the variable. Suppose we have written 6, but 7 can be written in terms of x raised to power of 0, always equal to that one. Because 1 is multiplied to everyone. So 7 is equal to 1 into 7, 1 into 7, and it can be written in the power of x raised to power into 1. So degree is 0. Any polynomial expression of degree is 0, that is known as the constant polynomial. Okay. Any polynomial expression which degree is 1, that is known as the linear polynomial. That is known as the linear polynomial. For example, 2x plus 9, 3x plus 6, 6x, 5x, x. These are linear polynomial because degree of each polynomial is equal to 1 here. Degree of each polynomial, that is 1. If a polynomial expression have the degree 2, that is known as the quadratic polynomial. That is known as the quadratic polynomial. For example, we have the expression 3x square plus of 4x plus of 9. This is the polynomial expression in the variable x, but a degree is here 2. So this is known as the quadratic polynomial. This is also quadratic x square. This is also quadratic polynomial. This is x square minus 9. This is also quadratic polynomial. Okay. Any expression which degree is 3, that is known as the cubic polynomial. That is known as the cubic polynomial. If the degree is 4, known as the biquadratic polynomial. That is the biquadratic polynomial. If degree is the 4, suppose we have x raised to power of 4 plus x cube plus of x square plus of x is equal to this one. So this expression of this form, any expression, we have the degree 4, that is the biquadratic, degree 3, that is known as the cubic, degree 2 known as the quadratic, degree 1, that is the polynomials, degree 0, that is known as the constant polynomials. Degree of the polynomial, multiple variables, already discussed with you. Expression of the form, for example is here, 3x square, this is written here, 3x square y plus of 2xy minus of 5y. That is the multiple variable, more than one variable. Okay. So here, this is the polynomial expression in x and y. That is the two variable x and y. So how to define the degree? Degree of each term. How to find degree of this term is equal to y raised to power of 1. Degree of second term is here x raised to power of 1 and y raised to power of 1. So degree is 1 plus 2. 1 plus 1 is equal to, that is the 2. First term. And for the first term, x have the degree 2, y have the degree 1. We have to just add. The degree is equal to 3. The first term have the power that is equal to 3. Second term, we have the degree 2. Third term have the degree 1. So here 3 is the highest exponent among all the terms. So degree of this given polynomial is equal to 3. So degree of this expression polynomial is here to 3. Now written example here, we have asked a question. 6x cube y square plus of 9x raised to power of 4 y plus 3x cube y or plus 6. What is the degree of this polynomial? What is the degree of this polynomial? What is the degree of this polynomial? What is the answer for that? What is the degree of this polynomial? 6x cube y square plus 9x raised to power of 4 y plus 3x square, 3x cube y plus 6. So we have to just add. Last expression have the degree 1, 0. Second expression have the degree. This is have the 1. This have the 4. This have the 4 plus 1, that is the 5. And this have the 3 plus 2 also is equal to 5. So highest degree is here 5. Okay. So expression will be taken in that order. So high degree is the 5. So in this way, we conclude the answer. That's format. Most of you given the right answer. Most have given the right answer. Most have given the right answer. Very good. Now, some standard calculation we have to just see the table. I'm going to explain with you that we have the zero polynomials. Zero polynomials, degree is not defined because standard form, degree 0, example is the 0, degree is not defined. For the constant polynomial, degree is 0. Expression in this form of x is equal to a, b, c, like that. 5, minus 20, and so on. Linear polynomial, degree is 1. Expression, general expression, px is equal to ax plus b, where a not equal to 0. A coefficient of x must be non-zero. Otherwise, it becomes the constant polynomial. If a is equal to 0, it becomes the b, or becomes the constant polynomial. So coefficient of the highest power of degrees must be non-zero. Okay. So here written bpx is equal to ax plus b, where a not equal to 0 and a, b are the real numbers. For example, 3x plus 9, 2x, and so on. That is the two quadratic polynomial. That is the ax square plus bx plus, that is standard form. Ax square plus of bx and plus of c. That is standard form of the quadratic polynomial. Okay. At degree 0, 2. Expression like the 2x square minus of 5x plus of 2 and so on. Cubic polynomial with degrees here 3. Cubic is degree is 3. That is ax cube plus bx square plus cx plus t. That is general form is that ax cube plus bx square plus cx and plus of d. This is the general form of the expressions. And the same sequence biquadratic ax4 plus a bx cube plus cx square plus dx plus e. This is the general form of the polynomials of quadratic. So biquadratic polynomial degree 4, cubic polynomial have the degree 3, Quadratic polynomial have the degree 2, linear polynomial have the degree 1, and constant polynomial have the degree 0. And zero polynomial have the degree not defined. That's clear. Okay. Now types of the polynomial. Now the types of the polynomial. Types of the polynomial on the basis of degree. We have explained with you linear polynomial, quadratic polynomial, cubic polynomial, biquadratic polynomial, and so on. Now we're going to define the definition on the basis of number of terms. A polynomial expression has the polynomial have divided in the following category. First is the monomial. One is the binomial. Second one is the trinomial. Quadratic, that is the, and so on. It can extend on the basis of the terms. Monomial means any expression contains only one term. Only one term. Any expression, any polynomial expression. Suppose px is equal to, we have the expression x. This is the monomial. Any expression which have the two terms. Suppose x square plus of x. This is the polynomial with containing two terms. That is known as the binomial. Number of terms is 3 in the expression, that is known as the trinomial. Number of expression the terms is known as the 4, that is the quadrinomial. Number of expression more than have the 5, that known as the pentanomial expression. The number on the basis of the number of terms in a polynomial is defined in the category monomial, binomial, trinomial, quadrinomial, and pentanomials. That's it. So we have to know under the, we have given examples one by one. First is that monomial. A polynomial expression containing only one term is called a monomial. Containing only one term. So any expression of the form containing only one term, px is equal to, suppose we have the 6x. This is only one term, this is known as a monomial. 3 by 2x, that is known as only one term, that is the monomials, and so on. X cube, only one term, this is the monomials. X raised to power 5, this is the only one term, that is the monomials. Any expression containing only one terms, that is the monomials. Next, binomial. Any polynomial expression containing two terms is known as the binomial. Containing two terms known as the binomial. You have the expression in the variable x, px is equal to, suppose x square plus of x. The expression have the two terms. One terms, another is the second terms. Any expression containing the two terms known as the binomial. The expression here 3x minus 2. This is one term, this is the second term. The expression is the containing two terms known as the binomials. Here the other polynomial expression 5x square minus 3x. This is the one term, this is the second term. Expression have containing only two terms known as the binomial. Any polynomial expression containing two terms is known as the binomials. Okay. Next, trinomial. Known as the trinomial. Any polynomial expression composed of three terms is known as the trinomials. We expression of the form 3x square plus of 6x plus of 9. 3x square plus of x of 9. So this expression have the three terms. One terms, this is the second term, this is the third term. The expression containing of the three terms known as the trinomial. Trinomial. This is the trinomial. This is also expression of the form that is the 2 minus u square plus root 3u. This expression has the three term first term, second term, and the third terms. That is the example of the trinomials. Any polynomial algebraic expressions which contain number of terms is equal to 3, that is known as the trinomials. In the same sequence of the definitions, any polynomial expression with more than one terms, with more than, any expression of the form is containing more than one terms, more than three terms. Suppose these are the expression of the form here written here 3x ka power 4 minus 3x raised to power of 7 plus 9x raised to power of 2 minus of 5x plus of 16. You have the one term, second term, third term, fourth term, the fifth term. So this is the category of pentanomial, but more than three terms we generally not discussed here. Biquadratic and the pentanomial, sextanomial, these are so definition wise, but we generally read monomial, binomial, and trinomial. And after that, biquadratic containing the four terms, pentanomial containing the five terms, expression containing the six terms, seven terms, eight terms, and so on. So we have to just learn to the biquadratic expressions. Okay. Any polynomial expression with more than three terms, that is the format of like that. Now, most important that values of the polynomial. If Px is a polynomial in the variable x and alpha be any real number, then values of when replacing x by a in the polynomial expression is called the value of the polynomial x is equal to a denoted by pa. Suppose we have a polynomial expression px is equal to x square plus of 3x. Okay. And now we are going to find out put x is equal to this expression. So left hand side becomes p1. The value of the polynomial at x is equal to 1. This is the value of the polynomial. It's a definition. How to do? You have to put x is equal to 1. That is the 1 square and that is the 3 into 1. The answer is 1 plus 3 that is equal to 4. So this is the meaning of the values of the polynomials. We have another example. Suppose we have the polynomial x is equal to x square minus of 4. And what is the value of this polynomial at x is equal to 2? What is the value of this polynomial at x is equal to 2 here? What is the value of the polynomial x is equal to 2 here? 0. Very nice. Answer is 0 because just we have to put and replace the x with the value of this one. Replace this one. Suppose x have the value 2. So replace here x is equal to 2. That is 2 square minus of 4. So 2 square have the 4 minus 4 is equal to 0. That's value. Very nice. Suppose another expression x square is equal to x square plus 3x and plus of 2. And what is the value of x is equal to minus 1? What is the value of this polynomial x is equal to minus 1? So what I have to do? Put just x is equal to minus 1 square plus of 3 minus of 1 and plus of 2. So minus 1 square always have the plus 1. 3 minus 1 that is equal to 0. 1 minus of 3 and plus of 2. So 3 minus 3 is equal to 0. The value of this polynomial at x is equal to minus 1 is equal to 0. So this is the expressions. So this is the meaning of the values of the polynomial. Just replace x by that number in the polynomial expression and solve. Find the values. And that is the value of the expressions. Now we move forward some general terminology, how to add the polynomials. So in the same type of powers, combine the like term. Addition of polynomials, combine like power. Suppose we have expression here 2x raised to power of 7, x raised to power of 5 minus 2x1 and this one. We have to add suppose. So what have to do here? Just see x raised to power of x is 7 is here, but here is not in the second note. So we write here x raised to power of 7. Here x raised to power of 5 is here, but in the second expression is not. So it is written just way. But in the third, 2 minus of 2x raised to power minus 1 minus 2x raised to power of 2. And here is also written x plus of x square. So combine these two like of expression. To combine like expressions. So minus 2x square plus of x square is equal to minus. And answer is that one. In the same concept we have to use in the subtraction of the corresponding subtraction polynomials. Subtract the two polynomials in the same way. Just we have to subtraction. Suppose we have given example x square plus of 3x and we have to add with the x square plus 6x. We have the to add. How to add? These 3x square will be added to the like terms. 3x square plus x square is equal to means it the 4x square. 3x in plus 6x is becomes the 9x. So this is the expression. This is the meaning of addition and subtraction of the same thing. So when I'm going to add, we have to first see combine like terms. The degree of relative or highest degree of the terms involved. We also key the points. Multiplication is a very easy task. Suppose you have the expression 3x square plus of 9 and we're going to multiply next polynomial expression x cube. What happened? First of all, this is multiplied to this one, and after this is multiplied to this one. How to add? X square and the 3x square plus this is the 9 into x cube, like that. So what happened? It have the same base, like power, and when you multiply it, the added degree is going to be added. Okay, so fifth constant is a 3, and x raised to power of 2 plus 3, and is 9x raised to power of 3. So answer will be here 3x raised to power of 5 or plus 9x raised to power of 3. So when going to the multiply, we add the sum of the degrees. Just so first degree is here 3, here is the degree of 2, the x raised to power of degree is 5. That's it. So we in this way we can add the product by get the multiplication of the polynomials. And the same very easy tasks to divide a polynomials. To division of a polynomial, can be used by doing the division as synthetic division. Suppose we are going to divide the 5x raised to power of 4 by x. So division can be done by easy way. No problem at all. When we are going to divide any polynomial, this is written. Suppose you are going to divide the 5 by 3. So number of division is going to 3 one times, 3, that is the 5, 2. So there are 4 terms here. That is the remainder. This is the known as the remainder. This is known as the quotient. This is the known as the divisor. And this is known as the polynomials. The divisor, dividend, remainder, and the quotient. So written in the form of this one. So we are going to divide any polynomials px by divide the polynomial by dx. Okay. Quotient is here qx and remainder is here rx. So value of the polynomial x is equal to multiply the quotient with the divisor and add the remainder. So written is here px is equal to qx into dx plus of rx. This is the key point for determination of the division of the polynomials. Zeros of a polynomials. If for putting the value, suppose we written here x square, just we put 3x plus of 2. And just I ask you what is the value of this polynomial x is equal to 1. And we have put in here, so x is equal to minus 1. So we find the answer minus 1 square plus of 3 minus 1 and plus of 2. And finally we get the 1 minus of 3 plus of 2 and 3 minus 3 is equal to 0. So this is the expression, this is the polynomial expression, and we have put x is equal to minus 1, the value of the polynomial becomes 0. It means x is equal to minus 1 is a zeros of that polynomial. When putting a value in the polynomial, its value becomes 0. That value is known as the zeros of that polynomial. So here 5x square minus of 3x minus 2. When put x is equal to 1, value is going to equal to 0. So x is equal to 1 is zeros of that polynomial. X is equal to 1 is zeros of that polynomial. By putting the values of the for evaluation of the value of the polynomial at particular values of variables, it becomes 0. Then value of x, variable x is equal to is known as the zeros of that polynomials. That is known as zeros of that polynomials. The values of x for which polynomials equal to 0 is known as the zeros or roots of that polynomials. That is the most important things I have to use in next. Factorization of the polynomials. Polynomials can be factorized into simpler polynomial, which in this way. While this written is x square minus 5. Already we are familiar with x square minus of 5x plus of 6 is equal to 0. How to do that? Why we have to read this concept by division of the factorization of this polynomial by splitting the middle term. So what I have to do? We have taken the coefficient of x square. The coefficient of x square is a 1 and the constant term is just 6. So we have to multiply 1 into, so the answer is just 6. We have to take in all the factors of 6. So factor of 6 is equal to 1 into 6. 2 into 3. Okay. Now we have to take that factor if here is the plus sign. So by addition, we get the middle term, or we have the minus, and by difference, then getting the middle terms. So 2 plus 3 is equal to 5. So how to write this? X square minus 5 can be written as 2 plus 3 into x plus of 6. It can be like that. Okay. So x square minus of 2x minus of 3x plus of 6. Now taken the common here, x minus 2. Here you taken minus 3. This also x minus 2 is equal to 0. X minus 2 and x minus 3 is equal to 0. This is the expression. This is the factorization process. In this way, you can do the factorization process to finding the roots of the polynomials. Okay, that is a very good concept which you are going to read it. Symmetry of the polynomials, even or odd. Suppose we have an expression, polynomial expression x is px is equal to x square plus of 4. That's it. Okay. If we replace x by minus 1, what happened? Minus x square and plus of 4. That is equal to x square plus of 4 and is equal to the first tick one. To any expression, if you replace x by minus x, there is no change in the polynomials. That is known as the even polynomials. But any expression of the form, suppose your expression px is equal to x cube, replace it, x is equal to minus x, you have the get x minus x cube. So answer is a minus of x cube and minus of px. And we are replacing by x2 minus of x, we get the same answer but of the negative sign. The expression is known as the odd polynomials. So that is the good concept is here also going to discuss. Even polynomials, when replacing x2 minus x, there is no change. We get the same polynomial. And odd, when replacing x2 minus x, get the same polynomial but with the negative sign. That is known as the odd polynomials. So these expressions are odd and even. Common factor method. Common factor is also description. Suppose we have the common things is always appreciated. Which term is common to all the expressions? Suppose written here, x raised to power of 7 plus of x raised to power of 5 minus of 2x raised to power of 2. In all the scenario, if we read here, we get here x square is also common because 7 power is 7, 2 is also come. X raised to power of 5, 2 is also here, and x raised to power of 2. In the whole scenario, find x ka power 2 is always common. So here we take x raised to power 2 common. So here remaining term is 7 minus 2, that is the 5. X raised to power of 5 remains here. Here becomes x raised to power of 3. Here becomes only 2. So this is the common factor method to find out the solutions and the roots of the algebraic expression to find out the solution of next scenarios. Calculation of grouping, just I've discussed with the method of common factors. Factorization of difference of the squares. Factorization of difference of the squares. Division of the polynomials can be done by using division or synthetic divisions. So division, how to do it, that we have to take an example here. We have some recognized methods and algebraic expressions. So a plus b whole square. Already you are familiar with the concept. A square plus b square plus of 2ab. A minus b whole square, a square plus b square minus of 2ab. Next one is that a is x square minus y square is equal to x plus y and x minus y. This is the some common factors terminology you have to use. Suppose you are going to find out the factor x square plus 6x plus 9. What is the meaning of x square plus of 6 and plus of 9? So 9 is the expression. Suppose this x square and 9 can be written as a 3 square. And middle term can be written as 2x into 3. So here written a square b square 2ab means that x plus 3 whole square in a plus b whole square. In this way, we can recognize the factorization terminology to find the perfect square of the trinomial, which have the 3 terms. Difference of the cubes, we have some standard formulas here. A cube minus a b cube. In one bracket, we have a minus b. In another bracket, we have the a square plus b square plus of ab. Sum of cubes, a plus b in one bracket and a square minus ab plus b square in another bracket. We have example here, 8x cube minus 27. 8x can be written as 2x whole cube. 27 can be written as 3 cube. So here a and this is the b. Just put in the formula. A minus b, that is the 2x minus 3. And a square, 2x square have the 4x square plus ab. So plus 2 into 3, 6x and plus of 9. This is the expressions. In this way, we can conclude the expressions to find out the solutions regarding to the given context. Proposition using the synthetic division, simply we have to put the values. Suppose you are written here px is equal to this one, expression is x, this one. If you put x is equal to 2, its values becomes equal to 0. It means x minus 2 is a factor of this polynomial. That's it. When if you divide this polynomial, remainder is going to be equal to 0. So this is the another synthetic method to find out the division techniques. A linear expression has only one terms here. Polynomial px plus s equal to b. So here alpha is the constant minus a b upon e. Quadratic expression have the two roots. In quadratic expression have the two roots. One root, suppose we are going to alpha, the root is going to be beta. What is the sum of roots? Sum of root is equal to coefficient of minus x upon coefficient of x square. And product of root is equal to constant term upon coefficient of x square. And so on. That is so easy. So you have to use the formula just here. Just use and find the answer for that particular things. We have some example to describe our concept. We have to take it here like that. Suppose if we have the expression on the form and we have the two roots here, 4x minus root 3 x plus 2. So x have the values, x is equal to minus 2 by 3 and x is equal to root 3 by 4. These are two roots. Okay. So we can take one root as alpha, another root can be taken as the root as the beta. What is the sum? Sum of alpha plus beta, sum of roots. We have to add minus 2 by root 3 plus root 3 by 4. Answer is minus 5 by root 3. Product of roots. We have the taken alpha is equal to this one, beta is equal to root 3 by 4. And we have to multiply this root 3 is going to be cancelled. 2 is to 1 by 2, that is the minus 1 by 2. So by taking the examples, alpha plus beta means sum of roots and product of roots can be defined. And expression is the form. Suppose your quadratic equation of the form x square plus bx plus c. And it has the two roots alpha and beta. Then alpha plus beta is equal to minus b upon m, coefficient of x upon coefficient of x square. And alpha beta is equal to c upon a, constant term upon coefficient of x square. That's it. You have to use the formula. You have to know the formula. You can find out, give the answer for that particular things. Same way. We have also going to find out the alpha square plus beta square. Suppose you're going to find the value of alpha square by beta square. How one conclude? We know the formula alpha plus beta whole square. What is the value? Alpha square plus beta square plus 2 alpha beta. And we're going to find out the values. We have to separate this one. Alpha square plus a beta square is equal to alpha plus beta whole square minus of 2 alpha beta. So sum of roots and product of roots can be used to find out the solution for that particular things. Now finally come across the points, learning outcomes of the sessions. In this session, we have discussed about identify the degree, leading coefficients, leading terms of the polynomials, perform algebraic operations, identify the greatest common factor of the polynomial expressions. So this is our conclusions about regarding our polynomials. I hope you enjoy the sessions too much. And read, I always say with you, without reading, you can't get anything. So you have to read the topic very proper way and do the practice at the question you define. And your knowledge, 100% you will be enhanced and you will be comfortable in your subjects. So first you read, discuss, and do the practice. Without practice, you can't do anything. So happy learning to all of you. Any questions from your side, you can chat in the box. Okay, thank you everyone.